Welcome to 1.1a, What is Matter? By the end of this video, you will be able to identify states of matter from material and explain their properties. So shape, volume, energy, and strength of attractive forces. While watching this video, these are the expectations. You should only have this video open and you should be using headphones. Make sure to listen with purpose. Mind your time. Most video lessons should take no more than 10 minutes to complete. Take notes. If you have guided notes, fill in the missing parts. If not, a good rule of thumb is to write down anything in red. Answer the questions that are within the video. And pause and rewind as much as you need to. Your notes will be checked for accuracy. So, what is matter? Everything around you, your desk, your chair, and even people are all made of matter. Even things you cannot see, such as air, are made of matter. Matter is anything that takes up space and has mass. Mass is the amount of matter in an object. I think it's easier to figure out what matter is and isn't by using examples and non-examples. So some examples of matter include physical objects, plants, animals, a coffee table, pen, pencil, hair, nails, a cat, a dog. Those are all examples of matter. Some non-examples of matter include thoughts, hopes, dreams, non-physical objects. When we talk about mass, one of the most important laws of science is the law of conservation of mass. And that says that mass cannot be created or destroyed, it only changes forms. And so, what that looks like in a reaction is the mass of the reactants equals the mass of the products. And in simpler terms, whatever goes in must equal what comes out. So, for example, if we have this ball of clay and it starts as a ball, we flatten it and we break it up into many pieces. No matter what shape that ball of clay has, the mass of the total amount of clay doesn't change. It's still the same amount. When we talk about states of matter, there are four that we're going to look at. That's solid, liquid, gas, and plasma. So for solid, the shape of a solid is fixed, meaning it's defined. So it's not going to change when you observe it. It is what it is. The volume of a solid is also fixed or definite. It does not change. And so what the molecules look like is if this was a container of a solid, like a solid block, the molecules would be nicely aligned next to each other on top of each other, and they're not moving, and they're very tightly packed together. An example of a solid is like your pencil. So when we think about shape and volume for a pencil, the shape of a pencil doesn't change, the amount of space a pencil has or it takes up doesn't change, and the molecules of a pencil are very organized and they don't move. The next state of matter we're going to look at is a liquid. And so the shape of a liquid changes or is variable. And if you think about like the water in your cup or the water in your water bottle, and you change the way you hold it, the shape of the water in the container is changing. However, the volume or the amount of space the water takes up stays the same no matter which way you hold it. So, volume for liquid is fixed or definite, meaning it doesn't change. Water molecules or liquid molecules are still tightly or still close together, but because their shape can change, they can move around. So they're slightly more spaced out than a solid, and they can move around, but they aren't stationary. And there's no organization to it. So they're just like scattered all over the place. And like I said, an example of a liquid would be like the water in your water bottle or in your cup. Gas has a variable shape as well. And volume. And so I think the easiest way to think about what the shape and volume of a gas looks like is by spraying a Febreze can. If I were to stand at the front of the room and spray Febreze towards the back of the room, the shape of the Febreze that comes out is going to change because the gas molecules are spreading apart. And the volume, the amount of space that Febreze takes up, or that gas, is also going to change because as the molecules for the Febreze is moving, they're also spreading out. And so gas molecules are not stationary. They are moving all the time and they are spreading away from each other because they have so much energy. And so another example besides like Febreze is air. The last state of matter that we're going to talk about, and we actually don't talk about this one as often, but it's still good to know, is plasma. So, plasma is actually very similar to gas. The only difference is that plasma particles have so much energy that they actually have a charge, which means some of them are positive, some of them are negative, like you see. But plasma, the shape and the volume of it also is variable or changes just like a gas. And an example of plasma would be like lightning or like the nuclear what's it called? Like the nuclear cloud. That's another example of plasma. And when we talk about states of matter, we're really just going to focus on solid, liquid, and gas. And solids, because they don't move, they have the lowest amount of energy. And when we talk about the highest energy or the ones that move the most, we're going to be looking at gases. So that's an important note to also add down into your guided notes, is that solids have the lowest energy, lowest movement, and gases have highest energy and highest movement. So here's example question number 1. You have 3 states of matter: solid, liquid, gas. I want you to rank them from strongest, being number 1, to weakest, but number 3, by their attractive forces to each other, which means how strong are they attracted to the other molecules around them. So one's going to be really strong attraction, and 3 is going to be the weakest attraction. So I want you to go ahead and pause and try this on your paper, and then answer your. Nope, that doesn't make sense. Then put your answer into the video. Okay, if you are unpausing, you have answered this question. So our strongest is going to be a solid. And because solids are their particles are very close together, um, that means that they are going to have the strongest attraction to each other. Liquids are going to be in the middle. They're still close together, but not as close. So their attraction to each other is not as strong as a solid. And gases are going to be the weakest. And that's because they have the most energy and they're always trying to move outwards or away from each other. So strongest is solid, weakest attraction would be your gas. Example question number 2. You pour a spoonful of salt into a glass of water. I want to know what happens to the mass of the salt, the mass of the water, and the mass of solution. Do they change? Do they stay the same? And why do you say that? Write your answer on your paper and then put it in the computer and unpause when you're ready. So the mass of the salt and the mass of the water don't change. Like we still have the same amount of salt going into the solution and the same amount of water going into solution. But because our solution to start was technically just water, the mass of the new solution after we add the salt would be increasing. So this goes back to the law of conservation of mass, meaning whatever goes in must come out. So if the mass of the salt and the mass of the water goes in, that same amount has to come out, but now they're just combined together. So, in summary, there are 4 types of matter: solid, liquid, gas. And the reason I only have solid, liquid, and gas bolded is because those are the ones that we focus on the most. Solids have the least amount of energy, they don't move, but they have the strongest attractive forces to each other, which is why they're so close together. Gases have the most energy, they have the highest amount of movement of the solid liquid gas, and they have the weakest attractive forces because they're trying to move away from each other and spread out. And then lastly, mass cannot be created or destroyed, it only changes forms. So when we're looking at how mass changes, it's going somewhere, it doesn't just disappear. Now I'm going to have you close out of this video when I'm done giving directions, but the next thing you're going to work on is 1.1a practice.